Hello all, this is Parthiban Ganpati from Red Hat, working as a technical consultant, and we are going to have a quick session on Red Hat and cloud. As we all know about Red Hat, yes, it is an open source company with 15,000 plus employees, and more importantly, it is the first $2 billion company with 85 offices in 35 countries. The journey of this billion-dollar company started in the year 1993. In 1999, the company has launched IPO. In 2002, first official Red Hat Enterprise Linux has happened. Then on, Red Hat had put their legs in various software development tracks and acquired multiple companies and standing as a huge giant in information technology. As I have told earlier, every year company has significant growth in infrastructure related subscriptions, applications, and dev related emerging technologies, and also in training and consulting. As Fortune Global 500 companies like airlines, telcos, healthcare, and commercial banks are rely on Red Hat products. Here are few open source product portfolio where Red Hat products are getting built. These are products. What you see on the slide deck is where Red Hat is concentrating on. Yes, it's time for us to discuss about the topic called as Red Hat Certified Architect on Cloud. Yes, it's a slight difference from the topic which we have shown before. Now the issue comes in. Why there's a slight difference? So when we look into the slight difference, now each and every company is looking for a certified architect on cloud, because when they do consulting to the customers, yes, they have to showcase themselves as what is cloud and do we have ability to make your applications running very perfect. That's why now we are jumping into a new topic which we are going to speak about, Red Hat Certified Architect on Cloud. We have already done Linux at the time of graduation or post-graduation. Now, what would be the next step to showcase yourself in the job market? Hence, the Fortune 500 companies would know that there is someone in the market whom they were looking for. Ultimate aim of everyone in IT market is to become an architect. Not on the outdated product, as the entire world is running behind cloud, it's time to speak about cloud architect. There were few products from Red Hat which will help you to build yourself in cloud platform. They are Red Hat Virtualization, number 2, Red Hat OpenStack Administration, Red Hat Cluster Storage Administration, Red Hat Ceph Storage Administration, Red Hat OpenShift Administration, Red Hat Satellite 6 Administration, Red Hat CloudForms Hybrid Cloud Management. So these 7 products will tell you about what is the duty of a cloud administrator, and these 7 products is going to build yourself into a cloud architect. After we know better on enterprise Linux, which we have studied during our college days, now let's put our step forward towards cloud. The first step is virtualization. What is this? A new term? A new technology? Or exactly what is this? No, it is not new. A very old product in IT industry. What does that mean? It means IT manager want to bring down the cost and want to have more efficiency in technology or mechanism so that they can achieve more on the limited hardware. That's the start of cloud growth. Now, when we want to speak about virtualization, rather than having an operating system running on a physical hardware where we have very less efficiency, every IT manager has gone to make it as virtualized. Rather than having one single operating system, they have multiple operating systems running on the same physical hardware so that they can utilize the hardware very efficiently by reducing the cost of the IT data center. Yes, when we speak about virtualization, it's a centralized management of virtualized compute, network, and storage resource using the open source KVM hypervisor. The moment I start speaking about hypervisor, it's a small piece of software which we install on the base machine, wherein which I can virtualize my system. So when I say virtualize my system, for every virtual machine, we need to have a CPU, memory, and storage. With the help of this KVM hypervisor, I can schedule the CPU for the virtual machines. I can schedule the memory for the virtual machines. I can schedule the storage for the virtual machines. With the help of virtualization, I can do an automated workload management, scalability, and security features for the virtualized application. With the help of virtualization, again, I can optimize my current IT and integrate with future technologies using the RESTful API. The benefit of this RESTful API is that when we have a local application in the company and the developer want to integrate the local application with the enterprise virtualization, it is easy for them to do with the help of RESTful API. As we've spoken about virtualization, now we could see some examples of it. If you want to work with two operating systems in a given time, it is not possible. Hence, we depend on virtualization. So KVM is what we have spoken earlier. What KVM does is it schedules the hardware like CPU, memory, and storage, provide them to the virtual machine on their request. So we could have more virtual machines or more operating systems running on the same time. Enterprise uses the same technique and technology and drastically bring down the cost invested on the hardware and getting more efficiency from the existing hardware. Now we got few minutes to look into the overview of this particular product and its components. First, we speak about backend. We would be having this enterprise virtualization software running on top of Red Hat Enterprise Linux, which consists of JBoss as a middleware and Postgres as a database. We also have the ability to integrate Active Directory, IPA, or any other open LDAP authentication for the user authentications in this product. Coming into access methods, we can access this particular product via a web browser. We have different views for administrators and different views for regular users to access their own virtual machines. The biggest advantage is that we can integrate this additional product via a RESTful API. After we launch the virtual machine, we have to access the virtual machine. Coming into the virtual machine accessing, there are two ways a user can access the virtual machine. First is they can use a SPICE protocol or they can use a VNC viewer as their own preference. With this, we will be able to access the virtual machine as per the customer request. What's next? Yes, it's Red Hat OpenStack platform. Is it a new operating system or a product like Red Hat Enterprise Virtualization, or what is this? The advanced version of Red Hat Enterprise Virtualization is Red Hat OpenStack, or we call this as a cloud product. The major difference between Red Hat Enterprise Virtualization and OpenStack is scale up and scale out. For an example, in virtualization, if the request goes over the limit, we can expand the virtual machine by adding resources like memory and CPU. But the issue is that if the VM is getting broken, the entire idea behind this getting broken. Compared with OpenStack platform, when the request is reaching the threshold, a new instance is getting launched. And if the request drops below the limit, the instance would be crashed automatically. The entire management of launching an instance and crashing the instance happen automatically here. This is the huge difference between Red Hat Enterprise Virtualization and OpenStack platform. When we speak about cloud platform, we divide the cloud platform into three major categories. The first category is IaaS, stands for Infrastructure as a Service. The second category stands for PaaS, stands for Platform as a Service. The third category is what we call Software as a Service. When we speak about OpenStack, OpenStack falls in the first category, which called as Infrastructure as a Service. Here are the overview of basic services running on OpenStack. First, we speak about dashboard. To access and control all the components in OpenStack platform, we need to have a service called Horizon. Then we speak about compute. As I was telling you before, depending upon the load, the instances are getting created and destroyed. When an instance is getting created, we need to have some resource like CPU, memory, network, and storage has to be scheduled. This would be taken care by virtualization in the previous scenario, but when you come into OpenStack, those would be provided by this compute service, which is called as Nova inside the OpenStack. Now, coming into the block storage, we all know that to install an operating system, we need to have a standard hard disk drive. The hard disk drive for the virtual machines would be provided by the Cinder service. Now coming into the imaging service. To install an operating system, we need to have an operating system disk that would be provided by the GLAN service, meaning all your ISO files and VM images required to build the instance would be stored over here. So whenever we want to launch an instance, the ISO file and the images would be automatically taken from the GLAN service. We speak about Swift service. This is very much equal to Google Drive. We will never format the storage, and it is very much used to store all type of data, whatever we have. For an example, to store an Excel file, to store an MP3 file, to store a Word document, why not? More than like your regular job scriptings. The best part is that whenever you have an internet connection, you can access these files over the internet. Coming into the network section of OpenStack. When we say that we can access the content over a network, we need to have a proper network configuration. The entire network configuration is taken care by a service called Neutron. Now at last coming into authentication. Whatever data I store into this OpenStack platform, it should be always secure. So when I come into security, the entire authentication is taken care by a service called as Keystone, a very strong and reliable authentication mechanism. As we spoke about OpenStack platform, we want to know how different this from virtual machine mechanism. In virtual mechanism, we have to analyze the load, and as an admin, we need to create a new virtual machine depending upon the additional software like load balancer to split the load and to handle them. In OpenStack platform, as we have spoken before, when the load increases, a new instance would be getting created automatically, and the load balancing would be coming into the picture, and the load is being equally shared. When the load reduces, the virtual machine or the instance which we have created will automatically getting shut down, and the machine comes into normal state. This is the biggest advantage in the current IT world. Now let's come into storage. When we speak about virtualization or cloud, we cannot forget the storage, which is a very important part. Now let's not get confused between the few storage services we spoken in OpenStack platform with the storage what we are going to speak now. Those are the services inside the OpenStack platform which will get connected to the external software defined storage box. Now Red Hat provides two storage solutions. Number one, Gluster storage. Number two, Ceph storage. Now we would look into what is Gluster first, then we would have a look into what is Ceph. Gluster is a software defined storage which is very much useful for unstructured data. How Gluster works? By design, Gluster is a file share. In other words, Gluster storage can be accessed by clients by different file share mechanism. So client would not format the storage they get from the Gluster and mount them as a local file system. The biggest advantage is when the actual server which is providing the storage is not available for various reasons, the other additional servers would start the same service. In short term, we would not face any storage stale issue when the actual server is down. When we say software defined storage, it can be accessed via multiple storage clients, namely NFS, CAFS and Fuse depending on the client. When we look into the working mechanism, from the client side, we would be installing the additional software like NFS client, CAFS that is Samba share, and start probing the storage server. Once the requests have reached the server, it authenticate and the client provide the dedicated storage to the client. If the server which has actually provided the storage is down, the next server would take the responsibility for providing the same storage without any delay and without any I/O miss. Whatever operating system you use on the client side, server never worry about. But on the server side, it is just a logical volume disk which is formatted with XFS file system, and they are named as bricks inside the Gluster wall. So in easy terms, storage server expose them as a volume, and client will ever access method they want to access the storage they would access. Let's say that the client has sent a write request. In that moment, the server responsible for the storage allocation is down. Client would not get the acknowledgement for the write request sent within few minutes, the next server would take the responsibility and start writing the data to the disk. This is very interesting. Even due to storage server outage, we still have the client successfully completes the writing. With few understanding on cluster, now we look into another storage, which is CEPH, Ceph storage. Now the question comes, one more storage? Really, do we need this? What is the benefit of having Ceph when we already have cluster? To answer all your questions, yes, Ceph is also an open source software defined storage. Then the question comes, how much it is different from Gluster? Let's closely look into Gluster and its access method. By default, Gluster is a file share mechanism. When a customer is looking for a block-based, Gluster cannot help them as of now. Hence, we have a Ceph storage. It is also a software-defined storage, which is completely different from Gluster. In what means? Ceph is by default an object store. What is object store? It's quite simple. It is exactly the same way how we access Google Drive. All we require an internet connection and an application to access them. How this is helpful in cloud? When we speak about cloud, we can access the instance anywhere we have internet. In the same way, your storage would be also available. When you come into Ceph, Ceph can expose itself in 4 different ways. The first method is what we call RBD, otherwise Rados block device, which is equal to your block store. The second method is Ceph FS. It is currently in technical preview, which is equal to your file store. The number 3 is your Rados gateway. This is how your Google Drive works. As it has a gateway concept, we can access the storage directly from an internet. The number 4 is native exposure. We otherwise called as an API, stands for Application Programming Interface. Meaning, Ceph is the only solution in the market where it can serve itself as a file share, a block storage and object store to satisfy customer needs. Very important, the latest implementation of OpenStack platform happens with Ceph storage as a backend. As like as Gluster, Ceph also uses a term called OSD, which is a process running on the server-side disk which has been formatted with an XFS file system. So, if we have 100 disks on the storage box, we should have 100 services running on the backend. For example, when we have 10 machines with 10 disks, the I/O requests would be served by all 10 machines so that the access time got drastically reduced and the client have a better service time. Now, when the client want to access the storage coming from the Ceph, the next question is that in what way the client is requesting for. Is it a block or a file or with an API? Depending on the client request, the storage is being exposed to the client. By this way, most of the customers started feeling that they have got a very good solution for an online storage part. OpenShift is Red Hat's cloud development platform as a service. The free and open source cloud-based platform allows developers to create, test and run their application and deploy them over the cloud. OpenShift has a microservice-based architecture of smaller, decoupled units that work together. It can run on top of a Kubernetes cluster with data about the object are stored in etcd, a reliable cluster key value store. Those services are broken down by multiple functions. To have much more clarity, each and every application in OpenShift runs inside a container. Container, what is it? Yes, container are the private work area inside Linux kernel for that specific application. Meaning, it is an isolated space. When we say isolated space, we never worry about moving this container from one operating system to other. Moreover, we would not have any issues in the code structure what developer has written. It works very smoothly as earlier, even after the movement from one operating system to the other operating system. As your Red Hat environment continues to grow, so does the need to manage it a high standard of quality. Red Hat Satellite is an infrastructure management product specifically designed to keep Red Hat Enterprise Linux environment and other Red Hat infrastructure running efficiently, properly secure, and compliance with various standards. How it works? We would be having many physical machines running with Red Hat Enterprise Linux. Few could be on virtualization, few on cloud and container. Now, when we want to update the system, we need to have a strong maintenance software. This software in Red Hat is called as Satellite. Red Hat Content Network. This is where Red Hat would release the updates. Now, those updates would travel to your in-house satellite server. From your in-house, we have a capsule server which is otherwise called as local mirror of what Red Hat has. Foreman is an open source application used for provisioning and lifecycle management of physical and virtual systems. Foreman automatically configures the system using various methods, including Kickstart and Puppet modules. Foreman also provides historical data for reporting, auditing, and troubleshooting. Now we come into the next product, speaks about Catalog. Catalog is a Foreman plugin for subscription and repository management. It provides a means to subscribe to Red Hat repository and download content. You can create and manage different versions of this content and apply them to specific system within user-defined stages of the application lifecycle. Candlepin. Candlepin is a service within Catalog that handles subscription management. Pulp. Pulp is a service within Catalog that handles repository and content management. Pulp ensures efficient storage space by not duplicating RPM package even when requested by content views in different organizations. If you have office in other regions, you could have more capsule server deployed in different regions. As we have idea about Satellite, we would look into the usage. Each and every Red Hat product we are installing, we need to have subscription. Without subscription, we cannot get the updates from Red Hat. Why we need updates? If there is a security flaw happening in the software, Red Hat would find the issue and fix them immediately. After fixing those issues, the updates would be released. When your system is not registered or subscribed, you would not be getting the updates. When the security patch is not installed in your system, you are still exposed to the security flaws, which might lead to a great business loss. CloudForms. CloudForms management engine delivers the insight, control, and automation that enterprises need to address the challenges of managing virtual environments. This technology enables enterprise with existing virtual infrastructure to improve visibility and control, and those starting virtualization deployments to build and operate a well-managed virtual infrastructure. In other terms, CloudForms is a single and simple management console to maintain all the above mentioned Red Hat products. The architecture comprises the following components. First, the CloudForms management engine appliance, which is applied as a secure, high-performance, pre-configured virtual machine. It provides support for HTTPS communication. The second component, the CloudForms management engine server. The server resides on the application. It is the software layer that communicates between the smart proxy and the virtual machine management database. It includes support for HTTPS communication too. The third component, the virtual machine management database, otherwise we call VMDB. VMDB resides either on the appliances or other computer accessible to the application. It is the definite source of intelligence collected about your virtual infrastructure. It also holds status information regarding appliance task. The CloudForms management engine console. Console is a web interface used to view and control the server and appliance. It is consumed through Web 2.0 Mesh-UPS and Web Service WS management interface. The smart proxy can reside on the appliances or on ESX server if not embedded in the server. The smart proxy can be deployed from an appliances. A smart proxy agent must configure in each storage location and must be visible to the appliances. The smart proxy acts on behalf of appliances communication with it over HTTPS on standard port 443. As we have discussed various cloud products, for training and certification, enroll yourself for below courses. Red Hat OpenStack Administration 1, which is CL110. Red Hat OpenStack Administration 2, CL210. Red Hat OpenStack Administration 3, CL310. Red Hat CloudForms Hybrid Cloud Management, CL220. Red Hat Cluster Storage Administration, RH236. Red Hat OpenShift Administration 1, DO280. Red Hat Virtualization, RH318. Red Hat Satellite 6 Administration, RH403. Thanks for watching this webinar.